All right, let's talk about one of the biggest upgrades to happen to large language models, retrieval augmented generation. You'll hear it called RAG, and trust me, this isn't just some small update. It's a whole new way of thinking about how AI gets its information.
So we've all been there, right? You ask a super smart AI a question, and it gives you this incredibly confident, very detailed, and totally made up answer. Which brings us to the big problem that RAG was born to solve. Why do these amazing models sometimes just lie?
Well, there's a name for this. It's called hallucination. And it happens for a pretty simple reason, actually. A standard LLM is trained on a huge but fixed set of data. It only knows what it learned up to a certain point in time. It can't Google things, it can't check the latest news, and it definitely can't read your company's private documents. So when it runs into a question it doesn't have the answer for, well, sometimes it just tries to guess and gets it wrong.
And this is the perfect way to think about the solution. A normal LLM, that's like taking a closed book exam. It has to rely completely on what it's already memorized. But RAG turns it into an open book exam. Before the AI even tries to answer you, it gets to look up the most relevant, up-to-date facts from an external source. It's literally like giving it a perfect cheat sheet, just for your question.
So, how does this open book test actually work? What's going on under the hood to make this happen? Let's pop the hood and take a look at the entire RAG workflow step by step.
The whole thing really breaks down into three main stages. First, you've got to get all your information ready. Then, you have to translate that information into a language the AI can search through. And finally, the fun part, retrieving the right info and generating a solid answer.
Okay, so first things first, it all starts with the data. And this can be pretty much anything. We're talking PDFs, internal wikis, Word docs, you name it. The RAG pipeline starts by pulling in all these different documents to begin turning them into a usable knowledge base. Now, you can't just feed a 200-page report to the model in one go. It's just too much. So we use a technique called chunking. This is our first real technissimo. And all it means is that we're breaking down those big documents into smaller, bite-sized pieces that the system can actually work with. And this is where it gets pretty precise. A really common approach is to make sure every single chunk is a specific size. For instance, you might set the limit to 512 tokens. Now, tokens are basically words or even parts of words. This just ensures that all the pieces of information are nice and uniform. But wait a minute. What happens if a really important sentence gets cut right in half between two chunks? Great question. To prevent that, we build in a little bit of a strategic overlap. An overlap of, say, 20 tokens is pretty common. It just makes sure that the context flows smoothly from one chunk to the next, so nothing important gets lost in the cracks.
Okay, so we've got our nice, neat chunks of text. But how does a computer actually understand what they mean? That brings us to our next key piece of tech, the embedding model. Think of this as a special kind of AI that acts like a universal translator. It takes each text chunk and converts it into a long list of numbers, a vector, that magically captures its meaning. And where do we put all these millions of vectors? Well, they live in a special place called a vector database. Now, this is not your typical spreadsheet-style database. It's purpose-built for one thing and one thing only, storing these vectors and searching through them at lightning speed to find the ones that are the most similar in meaning. It's like a hyper-intelligent library for our AI. And here is where it all comes together. When you ask a question, the RAG system doesn't send it straight to the LLM. First, it turns your question into a vector. Then, it zips over to that vector database and finds the text chunks with the most similar vectors. It grabs those chunks and stuffs them right into the prompt along with your original question. That is the augmentation part of retrieval augmented generation. It's giving the LLM the context it needs to give a great answer. So how in the world does the database know which vectors are the most similar? The secret sauce here is a mathematical concept called cosine similarity. It's way smarter than just matching keywords. It's actually looking for meaning by calculating the angle between two vectors. The smaller the angle, the more similar their meaning is. It's pretty brilliant, and it's exactly how the system finds the absolute perfect notes for that open book test. Okay, so we've put together this pretty sophisticated system. It's finding data, it's augmenting prompts, but how do we actually know if it's doing a good job? I mean, are the answers any good? That brings us to evaluation, which is just as important as building the thing in the first place. When you boil it all down, you're really trying to answer three main questions. First up, relevance. Did the system actually grab the right documents for the question I asked?
Second, faithfulness. Did the final answer stick to the facts in those documents, or did it start making things up again? And finally, clarity. Is the answer actually helpful and easy to understand?
And get this, here's a really clever way to handle that evaluation. A lot of times, you can use a second LLM to act as a judge. You feed this judge LLM the original question, the info the RAG system found, and the final answer. And you ask it to score how well the first AI did on things like relevance and faithfulness. You've got AI checking AI, all to make sure the quality is top-notch.
All right, we've gone through all the technical details. Let's zoom back out for a second. Why is this such a big deal? Why is everyone so excited about RAG? Here's the bottom line. RAG takes a generalist AI, one that kind of knows a little about everything, and turns it into a true expert on a specific topic, your topic. It lets you ground the AI in your own private, up-to-the-minute data. That makes the AI more accurate, way more trustworthy, and lets you build things you never could before, like a chatbot that can have an intelligent conversation about your company's internal reports.
So that really leaves us with a pretty incredible question to ponder. RAG essentially gives an AI the ability to read and understand a limitless, customized, and constantly updated library of information. So, what would you ask it? If your AI could read literally anything you wanted it to, what would you want to know? The possibilities are just getting started.